So we're here at the example table, and in this video we're going to be talking about series. But let's first review the basics of sequences because we're going to use those to define series. So a sequence, let's say we have a sequence of terms a sub 0, a sub 1, a sub 2, a sub 3, a sub 4, and so on. And so when we're talking about a sequence, we want to see what value, if any, each of these terms approaches, or the sequence of these terms approaches. So if we have something like 1, 1/2, 1/3, 1/4, 1/5, we have a sequence approaching 0. When we're talking about series, though, we want to look at the sum of a sequence. So we want to look at a sub 0 plus a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, and so on. Now to do this, we're going to use sequences. So we have an obvious sequence here, namely the sequence a0, 1, 2, 3, 4, but we can't use that to define the sum directly. We're going to use what we call partial sums. So a sub 0 is the first partial sum. Let's call that S1. Then the sum a sub 0 plus a sub 2, this is S2, the second partial sum. Similarly, we have the sum a sub 0, a sub 1, and a sub 2. This is the third partial sum. So here now is another sequence. We have a sequence of partial sums. And this is how we're going to define the series. So let's say definition, we have a sub 0 plus a sub 1 plus a sub 2 plus a sub 3 plus ... This, by definition, equals the limit as n approaches infinity of S sub n, where S sub n are the partial sums. So we could also write this as the limit as n goes to infinity of a sub 0 plus ... plus a sub n. Right, this is just the definition of S sub n, the nth partial sum. If we want to use sigma notation, we can also define an infinite series to be something like this. The sum from I equals 0 to infinity, a sub I. And then, using the same idea, this, by definition, is the limit as n approaches infinity of the sum from I equals 0 to n of a sub I. Right, this notation here is just another way of writing this series, and this notation here is just another way of writing the nth partial sum. So when we're talking about series, one of the unfortunate things is that there are no general ways of determining the value of a series. There are some special techniques that will work in some cases, but in general, you can't expect to determine the precise value of a series. But we're going to take a look at one example in this video where you can. So, as an example, let's take the sum from I equals 1 to infinity, 1 over I times I plus 1. Now, you may already notice something strange. I have here I equals 1 to infinity instead of I equals 0 to infinity. But we could just rewrite this as a 0 and change these numbers to get the same exact series. This starting number doesn't really matter as long as we keep in mind that we're not starting at 0. Of course, here we can't start at 0. That's why I start at I equals 1, because if we start at 0, this becomes 1 over, the first term becomes 1 over 0. So it's a good place to start if we have no idea how to do anything. We can start by writing down the first few partial sums. So let's write down S sub 1. Well, S sub 1 is just the first term, so it's when I equals 1, this denominator is then 1 times 2. So S1 is 1/2. S2 then is 1/2, it's the first term, plus the second term. The second term is 1 over 2 times 3, so this is 1 over 6. And this 1/2 plus 1/6 is 2/3. S sub 3 then is S sub 2, which is 2/3, plus the next term in the sequence. So now I'm talking about the sequence of individual terms in this series. So this is 2/3 plus 1/12, right? So when I equals 3, we have 1 over 3 times 4, so we have 1/12. And if you simplify 2/3 plus 1/12, you get 3/4. Now you might already see a pattern. Let's do one more. Let's do S sub 4, and this is 3/4 plus the next term. When I equals 4, this is 1 over 4 times 5. So this is 1/20th. And if you add 3/4 and 1/20th, you get what you might suspect, 4/5. So this certainly suggests that we keep doing this, we're going to get we're going to get 20 over 21 and then 45 over 46 and so on. So the limit seems to be 1. Let's see whether we can actually prove this. And we'll do that by taking a closer look at these terms, 1 over I times I plus 1. And we can actually split this into two pieces. This is equal to 1 over I minus 1 over I plus 1. Now it's usually harder to go from this to this. However, once you see this right-hand side, you should be able to verify that this can be rewritten as the left-hand side. And you might look at this and object, well, how could you possibly be expected to know to do this? Well, like I said, there is no single general technique that will determine the value of any infinite series. So with very few exceptions, there are some general techniques that take care of certain classes of infinite series. But in general, you're going to have to think about creative things like this if there's going to be any hope of determining the value of a series. The good news about that, of course, is that you usually won't be asked to determine the exact value of a series. But nevertheless, we can rewrite this 1 over I times I plus 1 as 1 over I minus 1 over I plus 1. So let's now write, well, we already know what S1 is. Let's write S2 using this idea. S2 is 1/2 plus, and this is S1, plus 1/2 minus 1/3. So this is 1 minus 1/3. Right, now let's look at S sub 3. So S sub 3 is S sub 2 plus A sub 3. Right, and now we have S sub 2, which is 1 minus 1/3. Now A sub 3 is this expression when I equals 3. So it's plus 1/3 minus 1/4. These 1/3 cancel, and we're left with 1 minus 1/4. And this pattern, well, so this gives us 3/4. And this pattern continues. So let's look at S sub 4. S sub 4 is S sub 3 plus A sub 4. S sub 3 is, actually it's easier if we use the 1 minus 1/4 form for S sub 3. So S sub 3 is 1 minus 1/4, and A sub 4 is 1/4 minus 1/5. So now these 1/4 cancel, and we're left with 1 minus 1/5, which is 4/5. Now we know, indeed, that S sub 4 is 4/5, S sub 5 is 5/6, and so on. So, our original series, the sum from I equals 1 to infinity of 1 over I times I plus 1, is by definition the limit as n goes to infinity of S sub n, where S sub n are the S sub n's are these guys. So this is the limit as n goes to infinity of 1 minus 1 over n, right? This form here. Actually, I'm wrong. S sub 4 we have minus 1/5. So this is 1 minus 1 over n plus 1. But regardless, this second term is going to 0, so we're left with 1.